When we look out into space, it helps to have an understanding of the speed of light. We use it more often to measure astronomical distances than to measure the motion of physical objects. At first it might seem strange to use time and light to measure distance, but it is a very useful way to understand the astronomical vastness of space by calculating how long it takes light to reach us from different objects, such as the moon, planets, the sun, other stars, and galaxies. So how fast is it? Well, the speed is exactly 299,792,458 meters per second, which is just over 186,000 miles per second, or about 670 million miles an hour. Not only is this incredibly fast, but nothing solid, nothing with mass, can be accelerated to this speed. Our fastest spacecraft move at a fraction of 1% of the speed of light. However, we can accelerate subatomic particles to within a very small fraction of 1% of this speed, at places like the Large Hadron Collider at CERN in Switzerland. I plan to come back to this in future videos. Most people are familiar with the term light year. A light year is the distance light travels in 1 year. 5,878,625,373,183.6 miles, or 9.461 times 10 to the 15 meters. This last figure, for those who don't know, is abbreviated and expressed in System International or SI units, which all scientists should be familiar with. To write it out longhand, you need to move the decimal point 15 places to the right. In SI units, distance is always measured in meters, mass in kilograms, and time in seconds, and so on. All physics equations can be reduced to 7 standard units of measurement. This is a good time to mention that the speed of light is referred to as c. So the c in E equals mc squared means that energy equals mass times c, the speed of light, squared. How can we understand c better? One way I think is helpful is with the following thought experiment. Imagine that there is a very large mirror on the moon, angled so it is facing towards us. Now imagine you have a very large telescope pointing at the moon, so you can just make out this extremely large mirror. You happen to have a very bright light which you flash while looking through the telescope. You will see the reflection of the flash 2.6 seconds later. 1.3 seconds for the light to go to the moon, and another 1.3 for the light to come back. The moon is about 238,000 miles away, which is 1.3 times 186,000 miles, which is 1 light second. If you listen to the unedited recordings of the conversations between Neil Armstrong and Houston from the moon landing in 1969, you will notice a significant time delay. Neil seems slow to respond. If the recording had been made on the moon, Houston would have seemed slow to respond. This is because radio signals also travel at sea. They are similar to light, but further along the electromagnetic spectrum, so our eyes can't see radio waves, but our radios can turn them into something our ears can make sense of. So knowing what c is, we can say that the moon is 1.3 light seconds away. The sun is just over 8 light minutes away, 93 million miles, which is about 400 times further than the moon. You will notice that I use a lot of abouts and approximately's. One reason is that orbits are elliptical, close to circular, but not quite. The other reason is that we don't need great accuracy and very long numbers to get an idea of how it all fits together. Neptune, the outermost large planet in the solar system, is 30 times as far as we are from the Sun, which is about 4 light hours. The furthest man-made objects, the Voyager space probes, are currently about 4 times further than Neptune, which is still less than 1 light day. But this distance is tiny in the grand scheme of things. The closest star, other than our Sun, is Proxima Centauri, which is just over 4 light years away. Voyager 1 would take about 76,000 years to get there, if it were heading in that direction. The brightest star in the night sky, Sirius, is about 8 light years from here. It's not a particularly big star, but it happens to be relatively close. All the bright stars we see in the night sky are well within 1,000 light years. Those further away can only be distinguished with telescopes, but to our eyes, most of them are lost in what we call the Milky Way, the plane of our galaxy, as seen from within. We are located about 26,000 light years from the galactic center, in a spiral arm known as the Orion Spur. The whole galaxy is about 100,000 light years across. So if there were a technologically advanced civilization living on a planet orbiting a star more than 100 light years away, they would not be aware of us, because we haven't been broadcasting radio signals for long enough. For this reason, we are only just beginning our search for life and civilizations in other star systems. We've only scratched the surface so far. We're limited by the speed of light and the huge distances involved. The nearest large galaxy, Andromeda, is 2.5 million light years away. The empty space between our own Milky Way galaxy and Andromeda is over 20 galaxy widths. The known universe contains billions of galaxies in all directions. As we look out into space, we are effectively looking back in time. It takes the light from more distant objects longer to reach us. Because the universe appears to be very similar in all directions, we can, by looking outwards and back in time, get an idea of what the universe used to be like. I shall expand on this in future videos.